All right, I want to talk a little bit with you about formulas. There's a wide variety of formulas in a lot of places you'll see. What we want to do from the mathematical standpoint is, we're going to solve some formulas for a specified variable. One formula that we might talk about is this formula. It happens to be the formula for interest, simple interest. Interest equals principal rate times time. Doesn't really matter right now what it stands for. What we're going to do, though, with it is talk about adjusting the formula, I guess, a little bit, you might say, and solve it for a different variable. This obviously got I on a side by itself. It's solved for I. So I'm going to solve the equation for a different variable, and in this case I want to solve it for p instead. And so what that would mean, of course, is instead of having an I by itself in this equation, I want to have the p on its side by itself. So let me rewrite my formula and think about that. How would I go about getting the p on its side by itself? Well, obviously there I've got to get rid of the r and the t. And how would I do that? Well, the operation there is not showing, but if I were to put operations in there, it would be multiply. It's p times the r times the t is what is meant there. And so I need to get rid of something that's times p, two things that are times p, in other words. And so how would I do that? I do that by doing the inverse operation of multiply, and the inverse operation of multiply is divide. So I'm going to divide by my r and t, essentially dividing by r and by t. Because what that does is gets rid of the r and it gets rid of the t's. The r's cancel, the t's cancel on the right side. Now, on the left side, can't do anything there for simplifying. So it's just really going to stay looking like that. And of course on the right then I just have p left. Mission accomplished. So that's the idea behind what we're doing today in this lecture here. Just getting the variable on a side by itself. All right, well, let's look at a couple of other problems. Let's say we're going to solve for a w in this case, and the formula that we start with is 2L plus 2W. So I want to rearrange that formula and make it solve for W. Well, the complication here is that on the right side, I have W, but I also have another term, the 2L term, on that side too. So we've got two terms instead of just the one term as previously we had. And so when we have that, you're going to want to get your term that has the variable you want by itself. So I need to get rid of the 2L term. And remember, the way we get rid of terms like that is by adding and subtracting. In this case, to get rid of the 2L term, I'd have to subtract it. 2L minus 2L, that's 0, right? So we're going to subtract 2L from both sides. Now, can I combine the terms over here on the left, p and minus 2L? Well, I cannot combine those because, remember, to combine them we'd have to have like terms. Like terms have the same variable. These don't have the same variable. The 2L's, like we said, what we're doing there, go out, and 2W is all we have on the right. Okay, well, still need to get W by itself, so we need to get rid of the 2. So it's times the W, so to get rid of it, divide by it. P minus 2L over 2, that equals W. There you go. Okay? All right, now, that's one form of the answer. However, let me point out, because of the nature of these things, and we're not actually getting a specific number here, we're getting, an expression over here, there can be more than one answer for in this case, for our W. And let me show you another form of this answer. Another form of this answer we could get if, noting here that this 2 here divides both the P and the 2L. If I divide both of those individually by 2, which is what that means, I can get the 2's to cancel out there and wind up with P over 2 minus L equals W. A second version, if you will, of my answer. Perfectly fine answer. Either one is correct. Which one's better than the other? Really depends on your perspective, I guess, but either one's fine. Either one of those answers is a perfectly fine answer. Now, let's talk about this, though, because a lot of times there are some who would want to do this. Hey, why don't we just cancel those 2 and wind up with just the P minus L? Well, of course, that is incorrect. You cannot do that. And it's for the very reason we just really talked about down here. That 2 is dividing both the P and the 2L. And if we just cancel it with the 2 there, the 2 on top with the 2 on the bottom, we would wind up with P minus L equals W. And we have not divided the P by 2, which it does need to be divided by 2 as well. So, yeah, this, be careful with that. And don't cancel when you can't. All right? Now, let me mention this one to you. Kind of has a technique that I haven't mentioned in my lectures here yet that sometimes comes in handy with these formulas. Let's say I've got an M equals 2/3 K minus 4B. I'm going to solve that for K. Well, we might start it similarly to our previous problem there. We've got the K term here, but we've got the 4B term here. It's minus 4B, so I'm going to move it to the other side by adding it to both sides. 4B, add 4B both sides. Not like terms, so M plus 4B is what I have on the left. 2/3 K is what I have on the right, because those will essentially take care of one another there. Okay? All right, now, here is the technique I wanted to mention. That is technically 2/3 times K, so we could divide off the 2/3, but let me show you this, which will give us a little bit nicer answer because we won't have the complex fractions that would give us. Yeah, if I run into a scenario like this where I have a fraction times the variable I want there, turns out if I multiply by the reciprocal on both sides, then a nice thing will happen. By reciprocal, of course, I mean the flip of that fraction. The reciprocal of 2/3 is 3 over 2, 3/2. So I'm going to multiply by 3/2 this side over here, 2/3 K. Well, if I do that on the right, I have to do it also, of course, on the left. Multiply by the left by 3/2, and it is by the whole side there, so I'm putting it in parentheses to do that, signify that. All right, so what happens is, the reason I do that is, notice I can cancel the 3's out because I got a 3 on the top, 3 on the bottom. The 2's similarly do cancel out. 2 on the top, 2 on the bottom, so I can cancel those out. Just k left on the right, which is what I meant to do in the first place. Solve for k. Got k by itself. There you go. All right. So let me try one more with that idea involved. My solving for the specified variable. Let's say I take c equals 5/9 parentheses f minus 32. All right, well, there you go. There we have the 5/9 times the expression, so might get rid of it by multiplying by its reciprocal. Multiply both sides by its reciprocal, 9/5. The 9's cancel, the 5's cancel. So I have 9/5 c on the left equals, well, that's gone. It's just 1. So I just have f minus 32 then left on the right. So if I want to here solve for my f, which I forgot to tell you, but that is what we're doing here. We're rearranging it. It's solved for c. I'm going to solve it for f. Yeah, if I do that reciprocal thing, then all I have to do is move that 32, which is going to be done by adding it, 32 both sides. There you go. Got my f on a side to itself.